is polynomial functions. Okay, we got our learning goals there. We're going to identify the different parts of the polynomial function today, figure out how to classify it based on number of terms and degrees, and then you're going to, tomorrow, start graphing that a bit more. We're also going to use our calculator to come up with some stuff today. Just a few quick notes. All right. Make sure everyone gets that. Yeah, Mitch?
Can we get that page in notes for the final?
We'll talk about notes and everything. You should be doing your portfolio for your final, right? Okay. Just going to start teaching, and then once the drill happens, we'll deal with it. Okay. The degree of this polynomial function. The way we classify by degree is we look at the leading coefficient. That means the variable with the greatest power. Okay. The variable with the greatest power has the leading coefficient attached to it. So in this case, the leading coefficient's 2 because x is raised to the third power here versus here where it's raised to the second power. The greatest power of x is 3. So classify our polynomial based upon the greatest degree, which is our power, of x, or of your variable. So in this case, we have x as our variable, so the greatest degree is 3. So this is called a cubic. It's a cubic polynomial. Okay? So that's how we're going to classify them today. We're also going to classify by the number of terms. And please note that terms are separated by addition and subtraction signs. All right? I assume we all know that. Any questions there? Everyone got this down? Stuff you need on here? Who needs more time on this part? Okay, we'll go for another minute or so there. Those of you that are just waiting around, you could take out 6-1 and your exponent work from Friday. We're going to be grading both of those today. Sounds like most of you are done there. So, moving on. Page 261 of your textbook, if you're referencing that. But it's all right here as well. You don't necessarily need a text. Classifying polynomials, standard form. To get to standard form, just like we've done in the past, it means, Parker, done talking, means all like terms have been combined and put in order by degree. Okay? So not only combined, but you're putting them in order by degree. That means greatest to smallest. So I'm going to start referring to this term degree more and more, and I expect that when you guys hear the word degree, you're thinking of their power. Okay? They're put in order by the power. Okay? By its degree. So, if I'm writing these two polynomial functions in standard form, what would that be? And let me zoom in there for you. The letter A and B. Why don't you guys put those in standard form and compare with your neighbor there. All right, let's see. Standard form here. F of x equals, we're going to put our 3x and our 6x together, gives us negative 3x. Plus 5. There is standard form. Everybody got that one? Wow. Basic, yeah. All right. Here, y equals, greatest power is x cubed, and looks like we've got 3x cubed and 5x, or 2x cubes for 5x cubes. And then we've got an x squared and negative 4x's. Everyone get that? Okay. Any questions there? Standard form, okay, pretty basic, I hope. All right. Go ahead and answer that question for those polynomials. What's the degree of each? Tell your neighbor there. Maybe write it down in your notes. Okay, Chad, what do you think here? What degree? It is linear. It's a first degree, okay? X is to the first, and we have a special name for that. It's called linear. Okay, you guys know that. What's this one?
Cubic.
This is cubic. X is to the third. It also has a special name. It's called cubic. So first power, second power, and third power, that we have special names that we will use. Okay. This is on page 262. It's a table. It really sets up the names of them by degrees and terms. Actually, let me focus in here. Hopefully I can get this to focus right. It's a little better. Okay. So a polynomial, for instance 6, if that's our polynomial, I know that's not much of a polynomial, but it's a degree 0 because x is if you think if I had plus x to the 0 power here, okay? Excuse me, that would be 1. We can't have that. Okay? So if I just had a constant without an x in there, marker all over my hand, okay, the degree is 0. Okay? The special degree name is called constant. Number of terms is 1. We call that a monomial. The word mono means 1. Okay? If we have two terms, x is to the first power now. Okay? X is to the first power. If you guys need a book, you can use one, but I'll try to zoom in there a little better. Okay? X is to the first. There are two terms. It's a degree 1. We call that linear. So make a good note of this column right here. Okay? The number of terms is 2, and 2 is binomial, or the bi meaning 2. Okay? So you kind of think of it that way. All right? If we have the polynomial 3x squared, notice in this case the highest power is 2. The degree is 2. It's a quadratic. There's only one term in this one. So that one term, once again, we call monomial. Mono meaning 1. And then the last one we've got on here, notice this one has the highest degree of 3. Okay? It's a cubic. Notice it has the squared in there as well, but the highest one is 3, so we call it a cubic. It's got 3 terms in it. 3 terms meaning it's called a trinomial. Now if we go beyond degree 3, so degree 4, we're just going to call it a 4th degree. Okay? And if we go beyond 3 terms, for instance, 4 terms, we're going to just call it a polynomial with 4 terms, or with however many terms. Okay? So we get kind of generic after 3. All right. Any questions there? Okay, very good. So we're going to start using those special names. How many of you have heard all those names before? Okay, the goal for you is to be able to classify, make sure degree you go with these, and terms you go with these. That's going to be part of our goal today. So let's see how well you can do that there. Try it on these 3. Classify each by degree and number of terms. This is on page 262 if you're using your text. Okay, questions? All right, by degree, everyone, what's this one? Good, so quadratic. So by degree, we call it a quadratic. By terms, we call it? It's a binomial. Okay. All right, by degree, what do we call this one? Okay, we call it a cubic. Okay, 3rd power versus 2nd power. And by terms, we call it monomial. Okay. And by degree, what do we got this on this one? Quadratic. And by terms, we call it a trinomial. Good. Okay. Any questions on those? Okay, that's what you're doing today. That is going to be extremely helpful when we continue 6-2 tomorrow. Notice we spend 2 days on it. That way we can kind of really break it up so that you understand it well. I want to shift gears a bit with this, and I want to go into cubic regression on our calculator using graphing calculator. So if you don't have a graphing calculator, you'll need one for this, so grab one now. Okay, remind your neighbor if we are going to use cubic regression or quadratic regression or linear regression, and obviously you use that when you have a list, remind them how to get to a place where you can enter a list into your graphing calculator. Okay, can I get a volunteer to remind me now? Go ahead, Parker.
You go under stat.
Go in this. Oh, let me dim this screen a bit. Go under stat.
Then you click edit.
So edit.
And then you plug in your numbers under X.
Okay. And then I am going to plug in my numbers. And notice I've plugged mine in already. So you'll notice here it says find the cubic function to model the data in the table below. Please note this statement. Hint, set 1968 equal to 0. In other words, time began for this problem in the year 1968. So rather than putting 1968 in for time, you're putting 0 in. Okay, which means this is not 72 or 1972, it is? It is 4. Now, 1 would be 1969, right? Okay, and so on. And be careful because it's going to seem like a pattern until you get to a certain point in here and you're going to be like, whoa, that's messed up. Okay, and then we're going with time as our y. So here's our x, here's our y. Please note that when you're measuring, now this is kind of weird, they're saying time in seconds, but when you're measuring time in years and time in seconds, here they're saying, usually, I'm sorry, let me backtrack. Usually I tell you time is always your x variable. It's always your independent. Well, in this case, you have two sets of times, right? One's time in years, one's time in seconds. Well, the time in years or months or hours, that's generally always your independent. In this case, they give you a table and your top value is your independent. So that's your x, bottom's your y. Okay, let's get that stuff into your table there. All right, I'm going to zoom in a bit here, but just to make sure that everyone's clear, 0, 4, this is 8, and 12,
16, 20,
22.
24, 20,
8.
26. Be careful, this one only increases 2 years. Why? Because 1996 did not exist when this book was put together. That shows how old it is. Crazy, right? You couldn't go to 96 because it wasn't 96. We didn't have the facts from it. I guess 96 was, but we just didn't have the numbers yet. So here's your x, 0, 4, 8, 12, 16, 20, 24, and 26, and then your y's. Okay, so making sure your table looks something like that right there. You'll notice my list, I have the same number of x as I do y's, same in list 1 as list 2. Otherwise, you're going to get a dimensional error there. Okay? Yes?
So I accidentally messed up on my graph and I have an extra 0 at the bottom of list 2. So how do I fix that?
So you got a 0 right here.
Yeah.
Just go up and hit delete. Yeah.
You're a gradient.
Okay? Yeah. All right, let's go ahead and hit quit.
Isn't it 28, not 26? You have 26 on it.
Did I have the wrong number?
Yeah.
No, it is 26. At the end, you only skip 2.
I should have told you guys that. Okay. Find the cubic. It says find the cubic function to model the data in the table below. Well, we're going to find the cubic function by going in and calculating cubic regression. Now, they tell us it's cubic. That's how we know we're going to do that. And what we need to do is we need to go to stat, calculate. So click stat, go arrow over to calculate. And we are selecting cubic regression, which is, on mine, it's 6. Okay? And then it's saying, well, what list do you want to use? Do you want your x to be list 1? Yes. Y list 2? Yes. Okay? List frequency, we don't need to worry about that or that right now, and we just calculate. Okay? Calculate is, there we've got it, ax in the form ax cubed plus bx squared plus cx plus d A is that, B is that, C is that, D is that. Okay, yes? Did anyone else get this?
Yes.
Okay. So what we want to do it says a function to model that. Well, we want to write out y equals, and let's go to the nearest hundredth on this. Y equals 0.02, right? If we're rounding to the nearest hundredth, x cubed. Okay, everyone go ahead and finish up your function there. Turn off that light. 0.72 x squared plus 6.75 x minus, or no, plus 98.19. All right. So there's our function. Everyone have that?
1 to 9.
Yeah.
I got one.
I got 1, 9.
Yeah, it'd have to be, right, 18.
Oh, sorry.
Yep.
My bad.
All right, estimate the record in 98 using the cubic function as a model. There's a couple ways we can do that. One is we could actually put in what value for x. What year is 98?
Oh wait, yeah, 30.
Don't wait for someone else to answer it. Everyone tell your neighbor, what year is 98? Good. So 98 would be year 30. So we could put in year 30, x. We could make x equal 30. Or, on your calculator, does anyone remember how to put it into your y equals menu? Why would it benefit us to be able to get it into our y equals menu? What could we use then?
Graph? Oh, the table.
You could use your table, right? If you have something in your y equals, you could go to 30 on your table. Then you have your answer. Okay? So how do you put that equation, not the rounded form that we have, the actual amount, how do we put that into our y equals?
You plug 30 in for x?
Don't plug in 30. No, you need to get this equation in there.
Oh.
And we've done this earlier this year. I'll show you again. Here we go. We go to vars. Vars is like short for variables.
Where's that?
I don't think mine's in English. That's part of my problem. Unbelievable. Some knucklehead's been changing our stuff.
It's in Spanish.
Yeah. Well, I don't want to reset, so we're going to go to vars. And we're going to scroll over to where it says y vars. And this usually says equation, EQ.
It says parametric.
Yeah, it says parametric.
Oh, it does? That's not good. Oh, hold on. I'm sorry. Vars, we need to go down to statistics, which is 5. Mine says it in Spanish. Okay? I think yours is statistics. And now you want to go over to where it says EQ, not EC. That should say EQ. And then the first one says regression equation. Good thing I actually have that memorized. Okay? And that is our regression equation. Now, those of you looking at that, if you weren't in the y equals menu when you did that, like I wasn't, then nothing happened. So I got to go through it again. Thank goodness. I need practice with my Spanish. We go to vars. We go down to option 5. Go over to EQ. Option 1, regression equation. And there it is. The whole thing's in there now. Now you should be able to hit table and go down to 30. So if I don't want to scroll to 30, I'm going to go to table set, which is second window. And I want my table to start at 30. Now I'll click on table again, and 30 gives me 164.62. So using our model, 164.62. No, I can help you here in a minute though. So, no, here we go. Right back here. Do you think it's reasonable? What are we measuring here? we're looking at times, right? Men's slalom records. Okay, and 98 is a reasonable time, 164.62. Does it seem to be following that trend?
No.
Probably not. Okay, now you'll know that first of all, a cubic function works like this. This is the graph of it. Something like that. Okay, that's a real poor graph. Let's do a different one here. Okay, so you start down, if you have your XY axis, and let's say we're going through the origin, it kind of curls up and slides down. And if we're going, as our time increases, what's happening with our Y? It keeps going up forever, right? I mean, it doesn't ever come back down. So as the years increase, this is going to just keep going up. So your time's not going to keep being reasonable. Eventually, a cubic function is not a good model for this anymore. You're going to have to use a different function. May not be a good model for 98. We could actually go back and check it since we're in 2014 now. So. All right? All right, now questions. Like, Christy, you were freaking out a minute ago. So what's up?
I don't know, it's just, there's a lot of numbers and they're wrong.
Did you get the y equals?
I think so.
So,
It all happened so fast.
okay. Hey, part of the deal with using calculators, you guys, you have to stay with it, right? So, do you have anything in your y equals? Okay.
I'll figure it out later.
Okay, ladies and gentlemen, your assignment. Eyes and ears right here, please. Do not cross anything off this page, but turn it over, please. Your assignment is the back, all. Okay, do not skip number 22 because it has words. Okay, you just did one like it. All right, there you go.